All right, we are continuing on to 4.10. Yesterday we completed formal proofs using SSS and SAS, and today we're going to be looking at how we can use ASA and AAS to prove that triangles are congruent. It says, use the diagram to determine how you know each of the pieces of information. So how do you know B is the midpoint of DA? And that's because it's given. How do you know the BA and DB are congruent? It's because of definition of midpoint. How do you know that those lines are parallel? It's given. Whenever you hear that lines are parallel or that sides are parallel, that's usually going to lead to AIA, AEA, or CA. In this case, it says, how do you know that that angle ABC and angle D are congruent? And that's because corresponding angles are congruent, corresponding angles theorem. And then I know that angle A and angle DBE are congruent because it's given. And then lastly, when you have all that information, you'd be able to finish your proof by using ASA. So this is just not written into our normal proof format that we had looked at, which was either a flow proof or a two-column proof. Now, what you're going to do is you're going to fill all that information into a flow proof. So you know that you have two different things where you have a given and that leads to something else. So you could have put the first one being BC is parallel to DE or B is the midpoint of DA. Either way, it's going to lead to something. Make sure you know what it's leading to. So B being the midpoint of DA is going to lead to BA and DB being congruent because definition of midpoint. Then you have BC is parallel to DE, which leads to those angles being congruent by corresponding angles theorem. And then you have that standalone thing, which was just the given that angle A is congruent to angle DBE, which was given. And all that stuff comes together to be ASA. Now you might wonder, what is the difference between ASA and AAS? Well, if you look at your diagram here and you look at a single one of the triangles, you have two angles and the side between the angles. So that is why it is ASA and not AAS. If that side was, let's say, where BE is or where DE is, then it would be AAS. But that's not what we have, so it is ASA. Why can't the bottom box be the BC is parallel to DE? Well, BC being parallel to DE is going to lead to something, and that bottom box is just leading to the final answer. It does not have a space where you could talk about what angles are congruent. Next, 4, create a proof for the following. You can create a flow proof or a two-column. I'm assuming most people did a two-column proof just because it's a little easier. You have two angles that are congruent, you have vertical angles, and then you have another given, which is AE and DC are congruent. All of those are single-step standalone pieces, so they could be switched up into any order that you wanted. And when you look at this, you see that there's two angles, but it's not the side between the two angles that are congruent, it's outside, and that's why it's AAS. This next one, fill in the two-column proof with the following. So on here, the second step says something about AIA theorem. So if the second part is AIA theorem, I know I need to talk about how these sides are parallel right before that. And that's why I put AB is parallel to CD. Therefore, those angles are going to be congruent. Now, the angles that are congruent for the top and bottom being parallel are the ones that I showed. The other angles that also look like AIAs are only going to be congruent if the left and right are parallel. So that is angle ABC and DCB are going to be congruent by AIA theorem. Then you also had angle A is congruent to angle D, which is a given. And then you had your reflexive property. And that comes out to be AAS because you have two A's and it's not the side between the two A's that's congruent. It's outside of that. That's AAS. Now let's take a look at your homework. On this one, would the following two triangles be proved by AAS or ASA? That one is going to be AAS. As you can see, you have two angles in one of the triangles, and it's not the side between the angles that's congruent, it's outside. And that's why it's AAS. On here, you're just filling out the reasons, and then you're going to put it into a proof. So you know M is the midpoint of BD because it's given, therefore those parts are congruent because definition midpoint. A and D are right because it's given. You know those angles are congruent because all right angles are congruent. You have one last given, and then ASA. When you look at this, you have two angles and the side between the two angles. Now, when you stick it into here, you still have, it's like the old proof that we had. We have two different things where you're given something and it leads to something else. Both of those could have been switched if you want. So you could have put the stuff about the right angles up top and the midpoint in the middle. It would be up to you. You just would have to continue with the proof. As you guys can see here, it all comes together to be ASA. In numbers 2 and 3, if you wanted to prove the end with AAS instead of ASA, you could have switched out the given, those angles are congruent, for which other angles being congruent. Well, if we wanted it to be ASA instead of AAS, if we wanted it to be AAS instead of ASA, then that would have been angle A and angle C being congruent, because then you would have had two angles that are congruent in the side, not between the two angles. The next one, complete flow proof for the following. Since the second one is talking about the angles that are congruent if there was an angle bisector, I knew that that angle bisector part had to go first, even though it does not come as the first given. Then those angles are congruent by definition of angle bisector. You have your other given, reflexive property, and AAS. Next one, Kendra says the following problem should be proved by AAS. She shows where she sees two A's followed by an S. What's her mistake? Well, what she did was she saw two A's, but one of the A's came from one triangle and one of the A's came from the other triangle. You can't do that. You got to look at a single triangle. When you see that it is given that two sides are parallel, you know that you should be looking out for what types of angles: AIA, AEA, and CA. Hopefully all that made sense. Thanks for watching.